So we're given some information in this problem. We're given the fact that the initial temperature of the body was 37 degrees. The environment's temperature was 10 degrees. At some time t later, the temperature was 27 degrees, and we'd like to find the value of that time. We're also given one more piece of information, which is that 1 hour later, the temperature had dropped to 24 degrees. Now we're going to be using Newton's law of cooling. Recall that's a differential equation, as stated here, and we've already seen the solution to that equation that we've got in front of us. Our task now then is to use the information to solve the problem. First of all, let's look at what happens at time t. The temperature at time t is 27 degrees. And according to Newton's formula, we know that that's going to be equal to 10 plus the initial temperature, which was 37, minus 10, multiplied by e to the minus kt. Now you'll notice that we have a constant here whose value we do not know. Part of the problem will be to determine the value of k and thereby also determine the time t at which this event took place. We have one more piece of information, which is that at time t plus 1, 24 is going to equal this expression times e to the minus, and here we write k times t plus 1, since this is at time t plus 1. Now let's simplify a little bit. Let's subtract 10 from both sides, and here we're going to get 17 is equal to, now the difference of this is 27 times e to the minus kt, and that's going to give us 14 is equal to 27. Now we're going to express this as e to the minus kt multiplied by e to the minus k. This has been expanded in order to give us these two terms. Let's call this equation 1, and let's call this one equation 2. If we take equation 1 and divide it by equation 2, we get 17 over 14 equals the ratio of these two things, and we observe some nice cancellation here. 27s and the e to the minus kt's cancel, and we're left on this side with e to the k. 1 over e to the minus k is e to the k. And from that, we can immediately deduce the value of k, which is going to be equal to the logarithm of 17 over 14. So we've done the first part of determining the unknown constant that we need in order to solve the problem. Now, how do we find the actual time? We can use either of these equations. Let's go for equation 1. So equation 1 tells us that 17 equals 27 e to the minus kt. We can rewrite that as 17 over 27 equals e to the minus kt. From here, we can actually write this in a more convenient form of 27 over 17 equals e to the plus kt. Remember that reciprocals also change the sign of the exponent. Now taking the natural logarithm of both sides, we get that kt is equal to the logarithm of 27 over 17. And so we can solve for t. It turns out to be 1 over k times the log of 27 over 17. We've already found the value of k. We can plug that in here and evaluate, and it turns out that this comes out to something like 2.3 hours.